So my chemistry project is about how glow sticks work. And so in this slideshow, we're going to be exploring how they function and the science behind them. So what exactly is a glow stick? Well, it's a unique self-contained light source that doesn't rely on external power like batteries or electricity. And so because they don't use power and are waterproof, they are really versatile. They are used for everything from fun at parties to critical safety during camping or emergencies. However, it's important to remember they are one-time use, and once the reaction is over, the light is gone. And so, why do they glow? Well, the gimmick behind the glow comes from a process called chemiluminescence. Unlike a standard light bulb that needs electricity to get hot and produce light, chemiluminescence uses a chemical reaction to generate light without heat. This is why glow sticks remain at a cool temperature even while they are shining brightly. And so if we want to understand the reaction, first we have to look at how a glow stick is built. And a glow stick consists of two separate parts. There is an outer plastic tube filled with a mixture of dye and a chemical called phenyl oxalate ester. Floating inside that liquid is a small, fragile glass vial containing hydrogen peroxide. The chemicals are kept separate until you're ready to use them. And so, to activate a glow stick, you first have to bend it. And when you bend the stick and hear that snap, what you're actually doing is breaking the internal glass vial. This allows the hydrogen peroxide to flood out and mix with the chemicals in the plastic tube. And as these two liquids swirl together, the chemical reaction begins immediately and the stick starts to glow. But what happens chemically? Well, for the chemistry behind it, when the hydrogen peroxide meets the phenyl oxalate ester, they create a very unstable compound called 1,2-dioxetanedione. This compound is so unstable that it breaks apart almost instantly. But as it decomposes, it releases energy. That energy is transferred directly to the dye molecules floating in the tube. The energy from the reaction causes the electrons in the dye to jump to a higher energy level or become in an excited state. The electrons soon lose that extra energy and fall back down to their regular level. And as they do, they release that energy in the form of visible light. And so depending on what type of dye that's used, we see different colors. And so let's look at the dye. Well, the dye itself doesn't just cause the reaction. It only reacts to the energy. Think of the electrons in the dye like a ball being thrown into the air. The chemical reaction throws the electrons up into an excited state, but it then gets pulled back down. And when that electron drops back into its original position, it produces a photon of light. To appreciate a glow stick, you have to compare it to a standard light bulb. Most light we use is incandescent, meaning it creates light through heat. But glow sticks use luminescence, often called cold light. Glow sticks get their energy from a chemical reaction it produces, while regular bulbs get their energy from electricity. This reaction from the glow sticks occur at low temperatures, making them safe to handle, while typical light bulbs operate at a high temperature. But the trade-off, of course, is that a light bulb can be turned on and off over and over whenever you need. But a glow stick is a one-time use tool. And so we've seen that a glow stick is more than just a cool gimmick used in parties. It's a portable, everyday example of chemistry and chemiluminescence in our everyday lives.